Hello everyone, welcome to Civil Mania. If you're new here, in this channel, I will break down real engineering calculations into simple steps you can actually use in design. So if you're into structural design, formwork, and practical engineering, hit subscribe. I post here regularly. So as promised, I have come up with a new calculation video. So today we are going to calculate the single-sided formwork anchors. The total load on the anchors coming, which anchor we have to choose, everything is here. So let's start. Now I have assumed a panel which is connected with the two single-sided frames. The height of the concrete is 3.3 meters as you see it here. So now at the height of concrete I will consider as Sy, which is equal to 3.3 meter. The influence between the frames Sx, which is equal to influence width. If it continues, then the influence width is 1.25 meters. Okay. Before proceeding, we should understand the type of anchors. So I mentioned it here, two types of anchor. One is the anchor loop and then the straight anchors. In the anchor loops and straight anchors, we have different thickness, generally DW15, DW20 and DW26.5. They have their individual capacities. DW15 takes up to 170 kilonewton, DW20 takes up to 300 kilonewton. If you have any other anchors, please ask your manufacturer the maximum load bearing capacity. Okay, so it's already mentioned here dW2 into 90 is equal to 180. Why I have multiplied with the 2? This means one straight rod can take up to 90 kilonewton load. So I have multiplied with the 2 because generally the anchors are placed like this. We have a single-sided bracket, then which is connected, which is the anchors are connected with the help of the rails. So here they have used two anchors with the angle of 45 degrees. Okay, now we have the two cases here. The first case I generally calculate without any assumptions, simple. We'll get a conclusion how is the load here. So first and foremost we need to calculate the concrete pressure for this one, for this height. So here we will use the formula as half into rho into h. If you don't know how to calculate the concrete pressure, I have already made the video. So please go into my channel and check the multiple videos I have made for the concrete pressure, slab design, rate of rise, everything. So everything is there. Go and please check it. So now we will calculate the concrete pressure, which is equal to half into 25, which is equal to rho, concrete density in kilonewton per meter cube. Then we will multiply with the 3.3, which is nothing but the concrete height. So totally we got 41.25 kilonewton per meter square. So let's assume the angle of anchor is 45 degrees. Generally it is placed in 45 degrees. If any other angles are there, please let me know. I will find a solution for that also. So the basic physics is when something acting and this 45 degrees or some angle, there are two force components. One is force x, Fx and Fy. So we already knew this formula that Fx is equal to Z. I am considering this as Z. So here it is written B, sorry, but it's Z. So Fx is equal to Z cos 45, Fy is equal to, that means V is equal to Z sine 45. The vertical component, H means the horizontal components. So you know sine 45 and cos 45 are equal. Why? Because it's already given there in the chart, because cos 45 is 1 by root 2, sine 45 is also 1 by root 2. That means I can say cos 45 is equal to sine 45. That also means that horizontal forces is equal, horizontal components is equal to vertical component. As simple. If there is any doubt, please write in the comments. So now we'll calculate the Z from this formula. One second. From this formula, we will calculate the Z value, which is nothing but Z is equal to H by cos 45. Cos 45 is 1 by root 2. Then we got the Z value as root 2 by H, which is equal to 1.41 H. Basic maths. Now, the next step is to calculate the H value. The H is nothing but concrete pressure P into Sx into Sy. So concrete pressure we already calculated 41.25, and Sx is the influence between the two anchors. It's 1.25, or the two frames, which is equal to 1.25. Sy is the height of concrete, is 3.3. It's already mentioned here, guys. Um, Now we got the H value is 170.15 kilonewton. So the Z is equal to 1.41 multiplied by 170.15. We got the total value as 240 kilonewton. Now the 240 kilonewton is nothing but this force here acting in this direction. So now we have to select the anchors for this area. I mean this situation. So we got 240 kilonewton. So DW15 doesn't work here, and also DW15 doesn't work because 180 is less than 240. So the next step is DW20. The anchor loops also gonna work, and the straight anchors also gonna work. But if the anchor loops are cheaper, DW20 anchor loops are cheaper than the straight rods, then I am going with the DW20 anchor loops, because it's very important at the site level to save some money, because there are hundreds of the anchors. Okay, this situation is, I think, clear. The case two is nothing but sometimes the situation arises then the client has already purchased some materials, like he has 1000 of this DW15, which has a capacity of 170 kilonewton. Then he told us, okay, I have this 170 kilonewton of one capacity of anchor loops. Now calculate me and give me the maximum pressure so that I can use this. So the situation is the case two. If you already have particular anchor and you want to know the maximum pressure allowed in it, it's the same formula, guys. We use the same formula. Instead of Z, we will find out P now. So Z is equal to 1.41 into H, 1.41 into P into Sxy, the same formula. Now we'll calculate the P, which is equal to 170. The 170 is nothing but the maximum capacity of this DW15 anchors. So 1.41 into P into 1.25 into 3.3. So finally, we get P as 29 kilonewton per meter square. That means we can tell the client in writing that if you want to use this anchor, the DW15, it's 170 kilonewton, then you have to maintain maximum of 29. So if it exceeds more than 29 kilometer, this anchor is gonna fail. So I hope you like this video. If this calculation helps you, give it a like, share with the engineering students or with the engineers. It helps more engineers to find this. I will see you in the next video. Until then, bye bye.